Hello everybody, here is my problem solution video. Our group decided that our definition of a problem was a situation that could be simple or complex that arises where we need to find a solution. The solution may or may not be easy to find. The problem I selected is out of our pre-calculus text. It's not a terribly difficult problem, but I picked it because there's one aspect of it that can sometimes trick the students, and I really wanted to focus on the 4-step problem solving process. So our problem is that a department store charges 1.25% per month on an unpaid balance for customers with charge accounts. And it does tell us that that's compounded monthly. A customer charges $200 and does not pay her bill for 6 months. What is the bill at that time? Well, what do we know about the problem? First of all, we know that it's 1.25% per month. I think it's important to point out that this is not the annual interest, and I think that's one thing that trips the kids up. That's a common mistake they have. This is per month. Okay. We know that it's sitting for 6 months. We know that it's $200 that's sitting there, collecting interest. The other thing that I would hope that the kids would come out with is that the interest is earning interest. Every month, that interest earns interest. So it's building. So how can we find it? Well, we could make a table and find what the bill would be for each month. And I think that's the most common one that the kids come up with, is because it's only 6 months, they can calculate that for each month. So we break out a grid. And they start calculating for each month. So we've got first month, second, through the 6 months that the money sits there. The amount that is on their bill at the beginning of month 1 is $200. And then how do we calculate the interest? And the kids are pretty quick to come up with the fact that we multiply the interest, which as a decimal would be 0.0125 times that amount. And we get a total of $202. Well, we get an interest of 50 cents, but that's a total of $2.50, excuse me. And that's our total. We may have to talk about where do we round to, because we're talking about money. You want to round to your nearest hundredth because we want every penny. So at the beginning of the next month, there's our amount sitting in the charge account, and we calculate the interest again and multiply, and we get a total interest of $2.53. And they add that into the account, they get a grand total of $205.03. And the kids continue working through this table. I have them calculating. So we start with 205. We multiply again by the interest rate, and we're now up to 256, which gives us a grand total of 207.59. That carries into the 4th month. And we get 259 added on. Two more months to go. Apply our interest rate. We now get 263 for that month, which is a total of 212.81. And our last month that it's sitting. Calculate, we multiply the interest to get 266, and we get 215.47. So, to answer the question, how much would be sitting in the account that she owes would be $215.47, according to our table. Now, checking. How do we know that's the right answer? Is there a better way to find the answer? A lot of times the kids are like, well, we have formulas. We have money formulas. Okay. What formula could we use? The most common one they come up with. Okay. Hopefully they will have realized that this is exactly kind of what we've done up in here to calculate the simple interest for each month. Other formulas, a lot of times they'll come up with a compound interest. Okay. Compound interest, so we dig out that formula. Hopefully a discussion would come up about the fact that, well, sure, we could use that, but we're going to have trouble in here where we've got the rate and the number of times that it gets calculated. Because this isn't yearly, as we said at the beginning, this isn't annual interest rate, this is a monthly interest rate. So can we accommodate this formula to work for that? And that would be a great way to verify it. So, if we do that, we would get 200, that was what was sitting on the charge card. Our rate is still 0.0125. But if we're talking about monthly and not yearly, if we can talk about time in terms of months instead of years, then I can say that this was once a month that we're calculating it, and we're doing that 1 times 6 months. And if we calculate that formula, we end up with $215.48, which I think would verify the fact that we did our table correctly. Something I might ask them after we've gone through this is, well, what would happen if we were given the annual percentage rate instead? How could we calculate that per monthly? Well, we could modify this so that it's 12 times per month and a half a year. Or we could take the annual percentage rate divided by 12, find the monthly interest rate, and do it this way. So there's a couple different ways that we could generalize to use this for future problems. Okay. Thank you.